Welcome to The Explainer. Today, we're unpacking a really fascinating architectural conflict living right inside one of the world's most powerful database engines. We're talking about the Oracle SQL join paradox. Specifically, we're going to uncover exactly why the legacy Oracle join syntax, that infamous little plus sign in parentheses, is literally breaking modern database architectures. If you've ever written a query and just wondered why your execution plan suddenly fell apart, well, you're definitely in the right place. So let's dive right into this.
All right, here's our roadmap for today. We're starting off with the blueprint of joins, then moving into the legacy syntax paradox, followed by critical restrictions and errors. After that, we'll take a peek inside the SQL engine, look at the modern ANSI solution, and finally, wrap up with standardizing for the future. Let's get to it.
Section 1, the blueprint of joins, setting the foundation. Okay, so we have our logical options here, your standard inner, outer, and cross joins. But what's really important is the actual data flow happening behind the scenes. Whether the database engine is utilizing a nested loop that pulls row by row, building a memory table with a hash join, or using a sort merge, these are the absolute fundamental mechanics that any SQL syntax has to communicate to the engine. It's the groundwork. Section 2, the legacy syntax paradox. Let's look at the core conflict.
I absolutely love this insight from a principal database architect. They said, mixing join syntaxes is like trying to speak two dialects of SQL simultaneously. The database simply stops listening. That really hits the nail on the head. It perfectly captures the paradox we're dealing with. We've got this legacy Oracle code using the plus operator, and then we have modern ANSI joins. But when developers try to combine them in a single query block, it's not just messy. The parser literally halts. It creates an architectural contradiction that the engine flat out refuses to process.
Section 3, critical restrictions and errors. This is where the system fails.
So let's talk about catastrophic parser failures. Imagine pumping ANSI SQL syntax into the engine alongside legacy Oracle syntax. When you try to use that legacy plus operator with an ANSI inner join keyword, it throws that massive, dreaded error that gives developers absolute nightmares, ORA 25156. It explicitly states that old-style outer joins cannot be used with ANSI join syntax. If you attempt this, the underlying data flow paths completely shatter. The engine won't even attempt a nested loop or hash join. It just throws up its hands with a syntax error and stops dead in its tracks.
And the mixing restriction isn't even the only barrier here. Say you're trying to use a legacy outer join operator, but you decide to add an in clause, like checking if a department ID is in 10 or 20. The very second you combine that plus operator with an in or an or operand, the engine's execution path shatters again. This time, it tosses an ORA 01719 error. The database essentially puts up a red shield and rejects the entire query. On the flip side, if you use a clean ANSI chain with left join keywords, it easily processes the in clause, flows smoothly right through the hash joins and nested loops, and you get query success.
Let's cleanly summarize these massive bottlenecks. The legacy plus syntax essentially carries three major restrictions you need to know about. First up, as we just saw, there's zero support for in or clauses. It simply cannot handle complex Boolean operators within the join logic. Second, there are no subqueries allowed. You can't apply the operator directly to nested query logic. And third, there is an incredibly high chain risk. If you're chaining multiple tables together with the old syntax and you miss just one single plus sign in that chain, boom, it collapses the entire outer join structure. And worse, it often silently converts it into an inner join, meaning you're returning totally incorrect data. Yikes.
Section 4, inside the SQL engine, the physical cost of all this parsing. Now, let's look at what actually happens to the optimizer. When legacy syntaxes fragment the parsing, there is a severe disconnect between the estimated plan, what the explained plan actually thought would happen, and the actual execution plan. Your CPU time and buffer gets just spike wildly. The optimizer struggles to map out efficient access paths simply because the legacy syntax artificially limits its ability to dynamically rewrite and optimize the query. It's like fighting with one hand tied behind its back. Building on that, when we look at a physical trace, it highlights the real performance killer. Ideally, you want the fast path going straight into memory, the PGA, and buffer cache, where hash joins are optimally processed. But because of the restrictions and the optimizer confusion caused by legacy syntax, the database is often forced to bypass memory entirely. Instead, it writes directly to the temporary table space on the physical disk. These direct path write and read wait events are painfully slow. You are literally forcing the database down the slow path just by using outdated code.
Section 5, the modern ANSI solution. Let's look at the clean, modern fix.
1999. Believe it or not, this is the crucial year. This is when the ANSI standard completely revolutionized SQL joins by introducing the ANSI 99 standard. Ever since Oracle fully supported this back in 2001 with Oracle 9i, they have formally recommended a full migration away from legacy proprietary operators and over to this standard syntax. It's literally been the industry benchmark for decades now. When you stack them up side by side, ANSI SQL completely outclasses the legacy plus operator. Readability? Legacy is super low, buried all the way down in the where clause. ANSI is high, explicitly stated right up top in the from clause. What about or and in support? It's not supported at all by legacy, which causes those nasty ORR errors, but it is fully supported by ANSI. And full outer joins? With the old syntax, you actually had to manually write two separate queries and union them together. ANSI just provides a native full outer join keyword. It's cleaner, it's faster to write, and it's fundamentally more capable. Section 6. Standardizing for the future. Preparing for cross-platform workloads. At the code level, the difference is night and day. The legacy method forces you to bury your join logic down in the where clause. This hopelessly tangles how your tables relate with how your data is filtered. It's a mess. The ANSI 99 standard cleanly separates all of this. Your join blueprint lives in the join on clause, and your data filtering stays safely in the where clause. This radical improvement in readability means you're going to see fewer bugs, way easier onboarding for new developers, and code that is just instantly understandable. And looking at the evolution of this, it's really not just a passing trend. We started with the birth of the Oracle Plus operator back in the 1980s out of pure necessity. Then came the 1999 ANSI standardization, followed by Oracle 9i support in 2001. Fast forward to today, and the market trend shows a rapid, steep decline in legacy syntax. Standardizing on ANSI is an inevitable evolution. Seriously, if you want cross-platform portability, meaning your SQL can run on Postgres, SQL Server, SQL Server, or Snowflake just as well as it runs on Oracle, you absolutely have to use the ANSI standard. There's no way around it.
Which brings us to our final thought for this explainer. Is your database still speaking a legacy dialect? Are your daily workloads silently suffering from optimizer restrictions, slow disk writes, and dangerous chain risks just because of code that was written decades ago? It is time to audit your SQL codebases. Drop that plus sign and finally unlock the full performance of your database engine. Thank you so much for joining me on this deep dive. Keep learning, keep optimizing, and we'll see you in the next explainer.